Okay guys, so in this video we are going to talk about REST, RPC and GraphQL. So let's get into it. So basically what we're going to cover in this video is what is REST, what is RPC and what is GraphQL and when do we use what, or at least a few ideas that hopefully will guide you when you're making that decision which one am I going to pick for this specific task. So let's start with REST. So REST stands for Representational State Transfer, and it is one of the two most common API interfaces that you pretty much will face as a professional developer, or just in general in web development, I would say. The other one being RPC, which is a little bit older, but still very, very common today. GraphQL would be the youngest of these practices, then it's still fairly new. But they all have a very nice use case, I think. So for REST, you can think of REST as being the sort. It's been designed in such a way that it primarily shines when you want to operate on some type of resource. Now, a resource is usually an entity such as a user, a product, something like that. It's an entity within your system. It's usually mapped to a specific so-called domain model that we have within the system. It can be anything from like a bunch of products to a user to all of these different things, right? Best way of thinking about it is probably it's a thing that you store in the database. Why we call that resource, that's up for you to guess, but that's what we call it. And what's really nice about this is that REST is a very good fit for a public-facing interface, such as, let's say that you have a business of some sort and you want to provide some type of functionality to a third party or something like that, that they should be able to modify certain things about the data or add accounts to your systems or do some type of integration or something like that. That is a very good use case for REST. It's a very common use case when you have someone integrating to your system. Now I'm going to show you an example of how REST can look, of this REST style, if you will. So this is my silly little server here, which is built with Express, and here you can see that I have a bunch of endpoints. Now I'm just faking this with databases and stuff like that because I don't have the energy to set all that up, and we don't really need to know about that in order to understand how REST works. So the most common thing that you will see with REST is that you have something like this, like API and a version number and then a name for the resource that you are operating on. So in this case, it's users. And conventions usually are that you simply stick to naming your routes in this fashion. Like you don't say something like user/list or something like that, because that's more of a RPC type of thing. Well, we're going to cover that in just a moment. But this endpoint here is basically doing is that I'm not specifying like I'm just doing a get on all users, and that gives me back all the users within the system. And now I use a post here and I do the same thing, and this is the convention that is probably the strongest associated with REST, that you use your URL or the route to just express the resource you want to do something with, but you use the nouns or like the method names of the different HTTP methods to express what you're actually going to do when you send that request. So if you go to /users and you do a get, that pretty much it's almost always that you're listing out all of those resources for the client. You just send back all the resources that you can find on under this domain name. And in a post, you create. So you post to the /users because there's no identifier or anything like that, right? And then we grab a name and then we create a user. We push that user into the database and then we return that user. That's also a little bit of a convention that if you create a REST should ideally always return something like a result set, and ideally that should be, it doesn't always have to be that in the case, but usually you want to return the resource you just created to the user, so that if they create a resource they can then find it, because it's kind of weird otherwise. If you create a user and you create a record in the database with an ID or something like that, well, if you don't return something back like the user that you just created, then the person who integrates to your system needs to go and list all the users and then find the latest record and then get the ID that way. And this is just a way for them to be able to get that information quicker. And then we have a put here, and now you'll see that we've actually added a little identifier here, and that's also perfectly fine. That's perfectly fine in REST, where you just say that, okay, I'm not just looking for like all the users now, I'm looking for a specific user. So I'm going to grab the name from the request here, and I'm going to find, or I'm going to go to the database and find a user that matches this identifier, and then I'm going to update their name, and then I'm going to send back this updated resource. And then you have the delete, which is fairly straightforward, I hope, which is the same thing. You find a specific user and you delete that user, and then you return the deleted resource. Don't have to do that, but it's a convention that I like, and I think it's a useful one. And then lastly, you can of course get a specific user. You just get that user that you are looking for. So these are the basics of REST, or how most people work with REST. You don't have to be so strict all the time about this. Usually you will find that in professional code bases there will be a mix between this style of working and RPC, and we're going to look at that, as I said, in just a moment. But don't treat what I just showed you as some type of die-hard rule that is like religiously followed by everybody. This is just the general convention of how REST actually behaves. The benefit to this is that it's a very well-established pattern of working. Most professional developers who do any type of integration or API-based work will recognize this pattern, and they will see very familiar. It's very easy. It's easy to understand, and it basically allows you the maximum amount of, pretty much the maximum amount of freedom, because this here is really only, like, there's no really complicated business logic or anything like that around this. It's really only a thin layer on top of a database. Now, of course, if you're doing updates and stuff like that, you might add some validation and stuff like this. This is just a simple demo example, so you don't allow people to just modify anything unless it's a trusted system that is doing the modification. But this is simple. It allows a high level of flexibility. The downside with this is that you can't really, in a resty way, express things that are not all that correlated to a resource. This is really optimized to helping you dealing with database records and things like that, and domain entities. But let's say that you wanted to do something that is not really related to this, like say send an email. Well, there's not really a resty way to say, oh, I want to send an email, because you're not really dealing with the resources in that regard. You're taking an action. That's what RPC is really good at, I would argue. And the other thing here is that if you have nested entities, you can be forced to do quite a few round trips in order to build up your state. Let's say that the user here has a list of comments with a bunch of comments that they have, right? Well, if you want to get a specific comment for this user, then you're going to have to go and get that user and get back a list of all the comment IDs likely that they have in a list on their model, right? And then you have to go to the comments REST interface and then just get all of those comments as well. So you have to do more. You have to request one resource to get to another resource. That's also something that can be bad with REST. A lot of back and forth on the network. Okay, so that's REST pretty much. RPC, Remote Procedure Call, is even older, I would say, than REST, and it's pretty much, I would say it's basically as simple as REST. It's probably even simpler. It's just, you can think of it as just being a function that you invoke on a server somewhere. You just name the function something, or the URL something that is correlated to the function, and then you call that function, and then it does the thing that it does. So if I have a look at my little RPC interface here, this is even smaller because I don't think I need all that much demo code to explain this. So here I've created an interface for something that I called send email. And that's kind of the example I gave you just a minute ago, where in REST, what you're dealing with is resources. And unless you have an email resource, that's not really going to be a good fit for REST. But if you just want to dispatch an email for some user or send a validation email or something like that, then a more RPC style of working or designing an interface it's very common. This RPC style of working or creating interfaces is, I would say, the most common for internal systems or for client to server systems, where there's not a third party. There's not like some other company somewhere who's integrated into your system. It's just your own system, like your own website or your something like that. And then it's very common that you kind of mix these things where, all right, so you create a send email API endpoint here so that when you're using your Vue application or like a Angular application or React or whatever, someone clicks on a link that should send them an email of some sort, well, then they hit this endpoint. Then this becomes it's very clean, it's very easy. This is like, I would say it's very common to see this. Like, it's hard to say which one is more common. I would say this is almost a little bit more common in smaller applications than REST, but they both occur in their own way, in sometimes even in the same code base, or quite often in the same code base. And this is also an example, run batch job. So let's say that you have some remote system somewhere, a server that knows how to do something like, I don't know, send out, as we were saying, emails or clean up the database from garbage data or something like that. Well, then that's not really RESTy either, because like you're not going to persist like it's kind of weird to say, okay, batch job. Well, you're not really going to a database to store the batch job. It's just a process that you want to start, or a job or something like that. And then RPC is a really good use case for that, where you pretty much just declare an endpoint like this, and then within the parameters, like if you wanted to, well, this is a GET request. It would probably made more semantic correct, be more correct if I said post, because I'm going to create a batch job. And then let's say that I had a bunch of functions here or something like that. Then the parameters to my function would be on the body or on the query. So I could have foo bar parameters, and I could just do like this. Body, body, it's even better than body, like that. So you can see, that's the best mental picture I can give you. Think of RPC as just being an endpoint that maps to a function, and this function is called run batch job, and the parameters are either on the body or on the query. It doesn't really matter all that much. And then you do some type of processing. And then this is another example. Okay, restart. Well, maybe you have some server somewhere and you have like a nice internal admin interface or something like that, where you want to restart a bunch of servers that is running in the cloud. Well, okay, then just create an endpoint where you send in a list of all the servers that should be restarted, and then this server here does all the job and does the job for you. So RPC, I would say, if we go back here, it has a really, really strong use case for all of these sorts of actions that don't really fit into like a resource or something you want to put in a database. Like, it's extremely common that you see most companies have these sorts of endpoints for actions that a user takes on one of their interfaces, or in maybe their internal systems, like they have their own network of services, then they talk to each other and so forth. Then this is very common. The downside with RPC is that it can get really, really confusing and messy for someone who doesn't have access to the code itself. Documenting RPC can be really tricky, because it can very easily lead to that you have, in a big system, maybe hundreds of endpoints, and if they all called like get message, create user, or things like that, these might be easy, but before you know it, all of a sudden you have like different versions of these endpoints, and then all of a sudden you have like all these weird business specific things like get, I don't know, free hugs on Tuesdays because it's winter. There's these all kinds of weird things that can happen with the names around these different methods. So usually developers who are working at the company will know what this means, so it's a very good fit for that. But it's not such a great thing, I would say, for external parties. So if you're making like a public API that someone outside of your company is going to use this as a very, like, if you have to use this very, very carefully, like just as a pinch of salt, or like a little bit of sprinkling of spices or something like that, and build more towards a RESTy type of interface, because most people, it's easier to keep a REST API consistent and clean than it is for most RPC interfaces and APIs. All right, so lastly, we're going to talk about GraphQL, and this is the new kid on the block for most of us, which basically is, you can think of GraphQL as this extreme mashup between, well, technically you can do both RPC and you can do REST through GraphQL if you really want to, depending on how you define these sorts of things. But the basic idea of GraphQL is just that you have a query system, or a query language, a graph query language, if you will, where you as the client, or the person, the browser or the client or another system, you declare a query, you send that to the server, and the server basically tries to comply with the query that you sent. The best mental picture I can give you is that you can think of GraphQL as being a database client and the server as just being the database. It's very similar to creating like an SQL query or something like that to a relational database, where GraphQL just gives you a specification, like and that's the query, and then the server is responsible to say, oh, okay, there's like, okay, this is the data that this client wants, and there's a join here, and like we're going to shape this data into the format that this client is requesting, right? So if we have a look at my Graph.js server here, it's a very small one, so I'm using Express and Express GraphQL here, which is just a middleware to wire all this up for me. And then I have my build schema function here because I'm going to build a schema, and we're going to look at that in just a moment. And here is, I have an outgoing message model, and here are my resolvers. And here's my tiny little Express server that just has this one endpoint. And I don't need all that many more endpoints for GraphQL because it's just one endpoint that deals with all of these entities. So I have set up GraphQL, which is just it's shipping directly with this middleware here. So I just enable that, and then I get this nice little interface for actually debugging and testing out my API, right? So let's say, for the sake of argument, that I want to get a message of some sort, and here I have a message ID, and we can have a look at my schema here. So this is what a GraphQL schema, a very basic one at least, looks like. So I built this schema, and I declared a type of a query, which is the top level query, which is just, okay, these are the different entities that I can get in, or these things basically map to the resolvers that I declare in my root resolver, my little object here. And basically what I'm stating here is that I have a function called message that takes a message ID, which is a required string, which is this little apostrophe here, and it was going to return a message. And a message is this type here. It has an ID, which is required, a text, a created at date, an author ID, and an author. And an author is just a type that it's just an object that holds a name and a created at time. And that's pretty much it. And here up I've just created some fake data to just represent this information here. So if I now just hit this here, you'll see here that it actually fetches this information. And this is the thing that is very nice about GraphQL, where you kind of get this for free, where let's say that I'm not really so interested in all of this other information here. I just want the text like that. And now I can query, and the database is actually just going to return to me this text field here. So I can it's a very flexible system where I can just declare myself what I want from the server, and I can get back the exact right amount of information that I'm actually looking for. I don't have to get all the things. I can just get what I actually want. Now you can do this in a RESTful way or in an RPC way as well, but this is a I would say it's a better experience for the person who's going to try to query to your system. It makes it fairly easy. So one thing that GraphQL does that is, I mean, it's absolutely amazing. I was so excited about that when I first saw it, is this idea of it solves a problem that REST cannot solve, or that REST has a problem with solving. And that is that thing I was saying, the roundtrips. So if you have a nested model where you have like a relational model a relationship between two models, then you usually need to get the first model before you can get the second model. And this is usually how it goes. So if, let's say for the sake of argument, that I wanted to get this message here, well, the full spec of my message was created at an author ID. So this is this is standard REST right here. You go and kind of get a message of some sort, and back you get an entity, which is the message, and it has an ID and how it has all this stuff, and then it has this thing here, the author ID. So now I know who made this message, right? But if I wanted the author, then I would have to do two requests. I would first have to go and get the message in a REST way, and then I would grab the ID from the message, and then I would get the author, which causes me 2 round trips, and sometimes this can be even worse. It can be many round trips. But in GraphQL, I can do this instead. I can just say author, like so. And of course, that doesn't work because I forgot to declare what I want from the author. And I just want the name from the author. I could say, I think, I can say ID and create that as well here if I wanted to. Like so, and I can say ID and I can get all the information. And no, I forgot. Okay, maybe I didn't add the ID to my spec. Okay, it doesn't matter. I can get the name and the created at least. I can add that as well, just because I added this, and then I'll say ID like so, and then we restart my server, we refresh, and ta-da, like so. Cool, so now I have all the author information immediately. So what I basically just did now is, from the perspective of me as the client, I did a join, because if we look at my message data here, there is, on this message data, there is only an author ID. There is no author. I haven't stored this in my database. I haven't stored all this information in, because it's a relationship. I have 2 different tables or 2 different systems that hold this information. And I just want to join this information to get all of this back in 1 query instead of 2 queries. And GraphQL allows me to do this. So I can specify this thing here, my type, and I can say, I can even remove this because I don't really need it. I can just say, I just want to get the author. And then I can, in my resolver, actually handle this. So in my root resolver here, I get the message, and my message now, we're just pretending here. Let's say that I'm just going to my database and I'm finding the message that matches this message ID. And then I declare a resolver like this. And the resolver takes in a bunch of fields. These fields are now open to query, as long as they're in the type. As you can see, they match here. I call this outgoing message just because it's like it's an intermediary model. It's just something that I send to the client. I'm not going to store it to the database. And all these things match up, with one exception. I set the author ID here, but I don't set the author. That's here. That's this method. And this is the powerful thing about the resolver system in GraphQL, where I can now say that, okay, if somebody wants the author field, well, then I can just figure out in my code here how to get the author model to that person. So I create a function that knows how to grab an author and returns this type. And as you can see here, that's pretty much what it's doing. So let's pretend here that there was another database query, like I needed to do a join, or maybe there was like some other system. That's also something that I really like about this approach, where you can create a single API, like a GraphQL API, that sits in front of maybe hundreds of microservices. I don't know how many. And the consumer of your API only has to know about one endpoint, which is this GraphQL server. And then you, as the developer, can actually implement all of the business logic for how to connect to all these other services to build up that payload that we want to send back. And that's exactly what I'm doing here. I'm just adding like a pretend database query here that grabs that author ID that I have from the main model, and then I send it all back in one request. So now the data I send is exactly what my client wants. They don't have to do any extra work or anything like that. And this is, it's so nice. So when it comes to GraphQL, the best use case, if you ask me, when it comes to GraphQL, is when you want to create a public API of some sort where there's a need for a lot of flexibility. As you were seeing, like if you're always going to send back the exact same payload, then it doesn't really matter if you can do this. But let's say that I am creating like a third-party integration to your system. Like I want to integrate to you, and all I want from the message is just the text. I don't care about all this other stuff. Well, then it's really nice for me to be able to just create a GraphQL query that just gives me exactly what I want. And the same thing is true for when you have more complicated models where you might have data that has a relationship to other data, and you need to connect this information or join it. Then this is also a really, really nice and powerful use case. So that's the one part of it. And as I said, the other part would be, it's if you have tons and tons and tons of different services that are needed in order to actually create some type of value, then it's really nice if you can abstract away the need for the client to know about this. Because if the client needs to know about, your 10, 20 different APIs that you have for getting different types of data, that's kind of a hassle. It's much simpler and a better user experience for them if they only need to know about one endpoint where they can grab all the data they want for their uses, right? The downside with GraphQL is that it's a lot more complicated. It's less people know how it works and so forth. It's very easy to learn this, but still, I want to mention that. It's also a little bit of a problem with versioning things, such as, I created a version number here for the entire GraphQL interface. So if I wanted to update something here, let's say I changed a model or something like that, then I kind of have to update the whole thing, and that maybe that's okay, but I can create like a version for this message resolver here. I could say version 2 if all of a sudden I want to return some other stuff here as well, or something changed about the model. REST usually just has one mapping to one resource, and then you just bump the version number like that. So that can be a bit of an issue, and this GraphQL way of working can, with the resolvers, especially if there's a lot of nesting going on, it can become a bit of a resolver hell, where it gets really complicated very quickly when you have all of these different resolvers getting data from different places. So usually I would say that for smaller APIs or simpler applications, GraphQL it's a little bit of overkill, because it adds more complexity. So what I want you to take away from this is that REST in general is a really, really nice way of creating a third-party API that feels clean and consistent to a lot of people, and it's perfect for when you're just dealing with data, when you're basically just dealing with a model or something that's going to be stored in a database. RPC is a very common pattern as well, very useful for internal systems, or when you want to do an action of some sort in a system. It's usually mostly used for that sort of thing. You can just think of it as a function that you call with some input on the net or the web. And finally, GraphQL is a really nice way when you want to have a very flexible model. Maybe you have a public API that there's tons of customers who are using, and they need different types of data and stuff like that. Then they can query and just grab the data that they actually want. Or maybe you have a lot of backend systems, different services that all need to be connected together to create one big consistent API. Then this is also a really useful use case for GraphQL. Have a great day.